Hello everyone, welcome yet again to CPRICT. In this video we are going to look at the problem C and D from today's Codeforces Riff round 1. Let's get started. The problem C is called ABBB. We have been given a string which consists the letters A and B, and if there is a substring in our string which is equal to AB or BB, we can simply remove that substring. And after performing these operations in an optimal manner, we need to find out the minimum possible length of the string which is remaining after performing all those operations. Suppose we are going from left to right in our string and we get the letter A. Then we cannot use this letter to remove any substring because we have only seen the characters which is to the left of this, and in VK we need to have these two substrings if we want to remove anything. So we would be using a stack to solve this problem. Whenever we see that our current character is A, we simply push it to our stack, and if we otherwise the character would be B. Then we see if our stack is containing any element or not. If our stack is empty, then we simply push this B in our stack. Otherwise, if our stack is not empty and we are seeing B at this moment, then either we would be having A in our stack at the top of our stack, or we would be having B at the top of our stack. If we suppose we are having A at the top of stack, then we can use that A with the current B, then it will make the substring AB and we can simply remove it. In that case, we will pop an element from our stack. And in the second case, suppose our top of the stack contains the character B and the current character is B as well. It forms a substring BB, so we can use that to remove that substring as well. So we would be using the pop operation. So yes, let's dry run this algorithm on the last example, which is AA triple B and A and then 4 times B if I'm not wrong. AA triple B. Yeah, so we would be moving from left to right. So let's say we are at this point and this is our stack. We see this is A, we cannot do anything from this by using this A. We push it to our stack. We see again we are seeing a character A. We push it to our stack. We see the current character is B and our stack is not empty. So we can simply use this A which is at the top of stack and remove this substring. So now this is being removed and we pop this element from our stack. Now we have moved to this index. We again see the current character is B and the top of stack is also containing A. So we can use this B with this A, which will form the substring AB. We can remove this AB as well. At this point our stack is empty. Then we go to this B, we see our stack is empty, so we cannot use a combination of AB or BB to remove any substring. We'll simply push this B into a stack, because in future if we see a B, we can use that B with this B to make a substring of BB and we can remove that. And yes, this turns out to be the case in this example as well. We'll see that. Now we see the current character is A. We cannot do anything with A. We are moving from left to right. We push it to our stack. We see now we are having a B and the top of stack contains A. So we combine this B with this A and we remove this substring. So this A has been popped. Now we move to this B. We see that the top of stack now contains a B. So we match this B with this B and we remove this substring as well. So at this point our stack is empty. We move to this point. As our stack is empty, we push B to our stack, and this is the last B. We see that our top of stack is containing a B. We match this current B and we remove both of these. So we see all the characters have been removed and the final minimum possible length of string would be 0. So yes, that's how we use the stack to solve this problem. Let's see the code now, which is very small. So initially I'm initializing my stack. Because there are multiple test cases, I'm making sure at the start of my algorithm my stack is empty, and then I'm traversing my string. If I see my stack is not containing any element, then I need to push it to my stack, whether irrespective of whether current character is A or B. And if I see the current character is B, and if I move to this else if condition, it also means my stack is non-empty, or you can say it's not empty. So if the current character is B and my stack is not empty, I can simply use the combination AB or BB, whatever the top of my stack contains, to remove that substring. So I pop my top of the stack. Otherwise I see then this character must be in A. Then I push it to my stack, and at the end I'm just printing out the size of my stack, which will be the minimum possible length of the string I would be having after performing all those operations. So that's all for this question. Now let's move to problem D. The problem D is called bouncing boomerangs. So a zookeeper has set up an n by n grid with some targets where each row and each column has at most 2 targets each. This is an important information. The rows are numbered from 1 to n from top to bottom, and the columns are numbered from 1 to n from left to right. For each column, zookeeper will throw a boomerang from bottom of the column below the grid, that is in the upwards direction. When the boomerang hits any target, it will bounce off and make a 90-degree turn to the right and fly off in a straight line in its direction. The boomerang can hit multiple targets and does not stop until it leaves the grid. As you can see, the boomerang which has been thrown from the column 3, it will first, which is marked in red, it will hit these 3 targets, and at the end it would be moving out of the grid from row 5. In the example, it is explaining the example. The boomerang in a column I hits exactly AI targets before flying out of the grid, and it is it is mentioned in AI per column. Zookeeper has lost the original positions of the target, so we have been given this array of AIs. We need to figure out whether using that array we can figure out the positions of those targets such that our condition has all the conditions would be satisfied. Valid, yes, we need to find out the valid configuration of the targets, and if we are not able to find any such configuration, we need to print -1. Otherwise we need to print the coordinates of all those targets. So let's see what we can do to solve this problem. So in this case, the value of AI would be 0, 1, 2 and 3. So let's see what we need to do for all these cases one by one. If the value of AI is 0, in that case our column must not have even one target. It should have 0 targets in that column. So in this we will be just neglecting this value and we will not process anything. We will not do anything. And if we see the value of AI is 1, then we need to place one target in that column. We'll put one target in that column and then we move ahead. And if we see the value of AI is 2, then as the value of AI is 2, then first of all our boomerang should hit a target which is in this ith column. Let's say the target is this, and then it should also hit another target as the value of AI is 2, and that target should be in the same row as of the first target. Then only it can move out of the grid. And if we analyze this, if we have got AI is equal to 2, and whenever we are placing a target in the ith column, then there must be another column which is to the right of this ith column. Let's say this is column J, which is having a target in the same row at which we are placing the current target. And if you see, this can only be the case when A of J is equal to 1. And why so? Suppose if a of j is equal to 2, then if a of j is equal to 2 and we are also placing the current target in the same row, then as this a of j is equal to 2, then it means it must have another target on the same row. Only then we can have this value of aj equal to 2. But if we place this current ai in the same row, then we can see that this current row is having more than 2 targets. But this is not possible, as it has been mentioned, all the rows and the columns must have at most 2 targets. And the same thing goes for 3, the case when ai is equal to 3. The examples which I have explained here as aj cannot be 2, similarly aj cannot be 3. So we need to match all the 2's with 1's. This is the only case. We cannot match a 2, we cannot match a 2 with 2, and we can neither match a 2 with the 2 nor with the 3, and obviously 0 as well, as we need to have another target on the same row. So this is a condition, a match. Whenever, so what we would be doing, yes, I will explain the algorithm later. So this is what you need to take care of at this point. So whenever you see ai is equal to 2, and there must be a aj which is to the right of our current column, which is having ai is equal to 1. And in the third case, if we see a 3, in that case our boomerangs should hit 3 targets, which would be looking something like this, and then it will move out of our grid to the left, going leftwards. Whenever we see ai is equal to 3, then we can use any other target, any other value of ai greater than 0. Let's consider all the cases. Suppose this current ai is equal to 3, so let's say I have put this new target at this column, then I can use ai which is having value is equal to 1. It means that column must be having only one target. But in that case, what I need to do is I'll place this aj in a row which is placed just in a row 1 up to the row where this aj is present. Then what we would be doing, let's say the coordinates of this ij is equal to i2 comma j2, and then this would be, as we are talking about the row, this would be i2 minus 1 and the column would be j1. So I would be placing another one more target just above this point. It would be having coordinates, you can say i2 minus 1 comma j2, and then after hitting that target it will move to this one, and after hitting that it will move to this one. So in that case, for ai is equal to 3, I need to add 2 more targets, and they would be placed at a row which is placed just one above the current row of my target which I am using. This was for when ai is equal to 1. I can also use ai where ai which is having a value 2. For that, let's say I'm having a aj which is having a value 2. So as the value of this aj is equal to 2, we must have 2 targets on the same row. And at this point, if I see the ai is equal to 3, what I can do again is just place a new target, a call which at a row 1 above than the row of my aj. This is 1. Then I will move to this rightwards direction and place another target just above this target, and after going there I move to this, and then I'll go out of my grid. So I can use for my ai is equal to 3, I can use all the cases for aj for 3, 2 or 1 except 0 to build up my solution for ai is equal to 3. So let's take example which has been mentioned in the problem statement itself, which is the first one. How I would be solving this problem is I'll move from right to left and I'll keep placing my targets in the lowest possible row as possible. Like I'll try to place them as down as I can, and I will be moving from right to left. And as I've already explained, for my all the values for where I'm having ai is equal to 2, I must have a 1 which is matching with my 2. Only then I would be able to find a valid configuration. And for 1, ai is equal to 1, I'll simply put 1 target in that column. And for ai is equal to 3, I can match it with 3, 2 or 1. See, so as for all the 2's, I must be having a 1. So I would be making sure I do not use the 1's with 3 unless it is absolute necessary. So for 3, I can use the 3 and 2's as well. So why should I use 1 first? As 1 is necessary for 2. So I should save some 1's, because in future I might be needing some 1 so that I can match it with 2's. So for whenever I see ai is equal to 3, first of all I'll try to match it with 3 and then I'll try to match it with 2, because these are useless except for ai is equal to 3. So if I'm not able to match any 3 with the other 3's and 2's, then only I'll try to match this 3 with a 1. And if I do not find a case where I can match this 3 with any of these 3, 2 or 1, in that case I cannot find such valid configuration. And also if in ai equals to 2, I cannot find ai which is to the right of my current column which is having a value aj equal to 1, in that case I also cannot find a valid configuration. And I'll said that I'll place my targets as down as possible. So let's try to derive and or take this example. I'll be moving from right to left. So I see this ai is equal to 1. So I try to place it as down as possible. So I can only place it at this point. So I placed it here. Then I see this. This is again I'm having a equal to 1. Now I cannot place it in this. If I suppose I'm placing this 1 at this place, then you see after hitting this target, then the boomerang will hit this target and it will move out of the grid by this. So in this case this ai turns out to be 2, but this should not be the case. So whenever ai is equal to 1, we should make sure that the place where we put a target, it should not be having any targets in the same row to the right of it. That is, this part must not contain any target, because after hitting this target our boomerang should move out of the grid. So the only place I can place this current target in this column as down as possible would be this. I cannot place it here. So I see for 0, I simply neglect it. Now the case is for 3. I said that I will try to match it with 3's. I see there are no 3's to the right of my current 3. There are no 2's. I'll try to match it with a 1. And the way I can match it, I'll put this 3 on a row just above places as I will try to place it as down as possible. I cannot place it here, because if I place it at this location, then after hitting this target it will move out of the grid and it will not be able to hit 3 targets. And if I put it at this place, then it will hit this target, and then I need to place a target here as well, but here also I cannot put a target because then it will not satisfy for this column. So the only place where I can not the only place, but the place which is as down as possible would be this. After placing my target at this location, then I'll place another target just above the one which I'm using. Then because then after this hitting this target, my boomerang will get out of the grid and ai is equal to 3. and for 2 I will do nothing, and for 0 I do nothing, and then I see 2, and I said that for 2 the only way I can match it is with the 1, sorry. And yes, I am maintaining an index which will tell me how many 1s I've used, how many 2s I've used, and also how many 3s I've used, and I'll keep using those 1s, 2s and 3s from right to left. So the example which I explained is not according to my solution. So after placing this character, I would be using this one. So I would be placing a target at this because I want to use my ones from right to left. So I'll make sure that after hitting this target, it will move out of the frame from the last row. And for this two, I need to match it with the 1 if it is I'm still left with some 1. So I see that yes, I'm left with some 1. So I place my new target in the same row for the one which I'm using. It will make sure that after hitting this target, it will move out of the loop. So these would be the locations where I need to put my targets. Let's see another example. Then in this case, my grid is of size 4 by 4 and the values of AIs are something like this. So I'll be moving from right to left. First I'll be putting the target here, and I'll see a 2. I need to match it with a 1. So I simply match it with this one, because after moving out it will only hit 2 targets. Then I see a 3. I cannot use 3 because there are no 3s on the left right of this part. So I see a 2. Yes, I have a 2 there. So I put a new target just in the above row for the 2 I'm using. I put another target just above this, and then it will move out of the loop, out of the grid. And then for this 3, I see if I am having any 3 to the right of it. Yes, I am having a 3. So I'll use this again in the similar way. I'll put a target in a row just above to the row on which my 3 is placed at, and I put the target, and that's how I get out of the grid. Now that's how I'm handling the cases. Let's see the code now. Yes, I think it got a bit complicated. I take the input. I see if it is array is equal to 1. I simply place it on the column, and this is the row which I am maintaining, which it will help me to place the elements as down as possible. Initially the value of this is n, and whenever I am placing any target, I decrement this row by 1, such that for my next column I would be placing that target on a row just above to the previous row. That's why I am decrementing this value. And this is for the case when array is I equal to 2. I see if I'm still left with some AIs which is having a value 1 to the right of my current column, I match it with that AI and I move on. And you see, whenever I'm matching a 2 with 1, I am placing them on the same row as of that one. So in that case, I'm not decrementing my row variable. And if I see the current AI is equal to 3, I see whether I'm left with or I'm having any 3 to the right of my current column. If I'm having any 3, I place it, I match it with that 3 basically. I need to put two targets to match it with that C. Otherwise, if I'm not having any 3, I check for the 2. I do the same for that 2 if I'm having any 2 to the right of it. Otherwise, if I'm neither having a 3 or nor a 2 to the right of it, I see if I'm having a 1 or not. Having a 1, I use that 1 to place 2 targets such that the value of current column is equal to A is equal to 3. That is, it satisfies the value of A equal to 3, and I decrement the value of my row. And in that case, it means I'm not able to find any 3 or 2 or 1. So I'm not able to find out a valid configuration in simple means. And this is the variable OK is equal to 1 if till this point I'm able to find out a valid configuration. And if at any column I see that at this column I'm not able to place the target at any place such that it satisfies the value of that particular AI. In that case, I put this OK is equal to 0 and break out of the loop. And if after breaking out of the loop I see OK, the value of OK is equal to 0, I simply read out -1 and return from there. Otherwise, I'm just printing out all the coordinates of those points. I store them in the vectors 1, 2 and 3. Yes guys, that's all for this video. It was pretty a bit complex, I think, but you just need to figure out the logic. The code is a little bit constructive motion. Yeah, even the problem tag is a constructive algorithm. So thank you for watching. If you have been watching this video till this point, please like, share and consider subscribing to the channel. I'll see you some other time. Till then, take care. Sayonara.